Good day and welcome to today's webinar, Introduction to the Insight D900 Series Vision Systems. I'm Josh and I would like to thank everyone for joining us. Before I introduce our presenter today, I'd like to share a couple items with you. If you want to ask a question during the webinar, you can do so by using the Q&A panel located on the left-hand side of your screen. We have vision experts on the line who will respond to you privately, and we will also answer some questions live at the end of the session. We also have our slides from today's presentation available to you for download. Today's presenter is John Rabicki. John is the Product Marketing Manager for Insight ViDi at Cognex. He has a Master of Science in Engineering from Purdue University. After 10 years leading new product development and implementation at P&G and SharkNinja, John joined Cognex in 2016. In his current role, he is responsible for implementing the Insight ViDi product roadmap and ensuring that new feature development meets the needs of customers. Welcome, John.
Thank you, and hello. In this webinar, I want to introduce you to the Insight D900 series vision system and its accompanying software, Insight ViDi. First, I'll explain why ViDi tools on an embedded Insight vision system will enable a breakthrough in the ability to automate factory floor inspections, followed by a recap of how ViDi tools work. Then, I will explain how you can use the Insight ViDi application software to train and validate these ViDi tools before deploying the Insight D900. And last, I will share the top types of applications the Insight D900 can solve that were previously thought to be impossible to automate. Like other Insight vision systems, the Insight D900 has an industrial IP67 rated housing, Cognex's HDR Plus image formation technology, and other common hardware such as 15 gigabytes of storage memory or a wraparound pass-fail indicator LED. However, for the first time, the Insight D900 combines Cognex's ViDi deep learning tools with our existing rule-based vision tools, such as PatMax Redline, on a single embedded vision system. This combination of tools will help you execute tasks and complete inspections that you might have struggled to automate in the past. To maximize online performance, the Insight D900 smart cameras are designed and built with 4 ARM cores and 2 inference engines to process ViDi tool results. And they currently come in 2 resolutions, 2.3 megapixel monochrome and 5 megapixel monochrome. Whether you're familiar with deep learning technology or not, let me explain what makes ViDi so different from rule-based vision tools. What makes deep learning in general so different is how it mimics the way humans learn using example-based learning. For example, look at each of these houses. To teach a child what a house is, you would never describe a long set of complicated rules, such as a certain number of walls, a certain percentage of windows, or a specific shape. Any set of rules you tried to prescribe will quickly break down in the real world with each next example of a house. Instead, you teach the child by showing him or her houses on your street, in your neighborhood, or these days, online. From those examples, the child learns the characteristics of a house, and in time, he or she can judge whether or not any given structure is a house. ViDi tools are trained using a very similar example-based approach. Let's look at a machine vision application, detecting defects on a conical automotive air filter. The air filters appear visually distinct depending on how the light reflects off the black wire mesh. And this high degree of tolerable variation between good images makes this a very tough machine vision application. And when you need to inspect areas around the silver joint in the same inspection, this application becomes nearly impossible to solve using only rule-based vision tools. You would struggle to even get started. But humans can easily segregate good filters from bad ones by quickly identifying dents or other types of defects with just a little bit of training. And by including ViDi tools on the Insight D900, we've now combined the reliability, speed, and precision of standard machine vision systems with the power and flexibility of deep learning. Deep learning has been around for decades, but ViDi tools analyze images more intelligently by only looking at the salient and task-relevant parts of an image. The way ViDi tools are designed improves speed, and reduces the number of images required to train an effective neural network for an industrial application. So how does ViDi work? Well, all ViDi tools follow the same fundamental workflow: collect and label images, train the tool, and validate the results. To dive into these steps a little bit deeper, let me now introduce Insight ViDi 1.2, the software that you'll use to set up your Insight D900. Insight ViDi is the first application that runs inside a new overarching software platform called Insight Vision Suite. You'll use this homepage to navigate the devices on your network and perform other smart camera level tasks, such as network settings, firmware updates, and managing job files. When you want to connect to an Insight D900, simply select the device and click Connect. Once connected to your device, Insight ViDi features a familiar and easy-to-use Insight spreadsheet, and the ViDi tools are found in the toolbox just above the standard rule-based vision tools. You don't need to have any prior programming experience to build the Insight D900 jobs or to train the ViDi tools. Let's review how you will set up the ViDi tools on the Insight D900 to perform that air filter inspection. First, you'll install the D900 vision system on your production line and connect to it through your network from your PC using the Insight Vision Suite homepage. Once you connect, in addition to the spreadsheet and toolbox, you will also have access to an offline film strip. You can import pre-existing images by dragging and dropping them into this film strip, or with the film strip's record functionality, you can easily collect images directly from your production environment and save them to your PC with a custom naming and numbering structure. Once you've collected the images, you will add your inspection tools to the spreadsheet. This can be a combination of the most popular rule-based tools from Insight, such as Cognex Redline, as well as any of the ViDi tools licensed for that D900. In our case, because we're performing defect detection, we will add ViDi Detect to the spreadsheet. From the property sheet, you can set a region of interest to pass into the ViDi tool for each image, including whether or not you're using another tool as a fixture. Then, to configure the ViDi tool, you will select Open ViDi Editor at the bottom left of the property sheet. From the ViDi Editor, remember the workflow we described earlier: collect and label images, train the tool, and validate the results. We already collected the images into our film strip, so again, we can just drag and drop them from the film strip directly into the view panel within this ViDi tool. And at this point, we start to call them views because it only looks at the region of interest set from your property sheet, not the entire image. Then for the ViDi Detect tool, you'll label those views good or bad, either individually or in bulk, and review the tool parameters. From this menu, you have access to many parameters which can help you optimize the neural network training for your application, including feature size and capacity of the network. The feature size is an important setting that determines how closely, in pixels, the ViDi tool evaluates each view in training and in production. And there's an interactive feature size bubble to help you visualize that. If you have an application where it's impractical or impossible to capture images of all the variation you expect to see in production, the ViDi tool parameters panel has a perturbation section that will let you simulate that variation. ViDi uses this information to copy and augment your views and then use those augmented views for training as well. And in this example, I included allowances for 5% additional variation in luminance or brightness and contrast. Once you've reviewed the tool parameters, click the brain on the tool pill to train the tool's neural network in a matter of minutes. The tool trains in the background using your PC's GPU, so you can continue configuring other parts of the job. By default, ViDi groups your views into two halves, a training set and a testing set. The training set is used while training the neural network, and the testing set is reserved to validate the resulting neural network after training is complete. So it's important to not only collect enough images to train the tool, but also to validate that the resulting neural network is providing meaningful results on new images it has never seen before. ViDi also has the ability to let you define custom image sets to better organize and track the performance of images inside the ViDi editor. Once training is complete, you will review the Database Overview tab, which visualizes data differently depending on the tool. For VidiDetect, the score histogram helps you visually understand if the tool can detect the difference between the testing set you labeled good and bad. And the tool adds a heat map for any part of the view which is deemed to display anomalies compared with the ground truth of images you provided. These defect regions are identified by the quality of the neural network, but also by how far above the green threshold they score. A good performing VidiDetect tool will have a clear or minimal gap between the good and bad labeled views from the testing set. Altogether, the Vidi editor provides you the interface and control levers to train and validate the neural network for each Vidi tool before going into production. And it's all contained within a single cell in the spreadsheet. Naturally, if you want to output some of the results data, such as score or defect blobs characteristics, you can also insert that data into the spreadsheet with the click of a mouse. Insight Vision Suite also comes with a free and powerful web page builder, which lets you customize what information is displayed from the Insight D900 to the HMI on the factory floor. These web pages can be displayed on an internet web browser using HTML5, such as Google Chrome or Internet Explorer, once your job is online. And they give you complete control over the way your data is presented to the operator and the way you allow an operator to edit the job while it is online. Once you complete building the job file for your inspection from your PC, you will want to put the D900 into production. Simply save or export the runtime job file onto the D900, and you have everything you need at this point to put your embedded vision system to work in the application without a PC. At this point, it operates just like all other Insight smart cameras as a standalone vision system that can easily be integrated with other automation equipment. Only now, it includes the ability to use Vidi tools to perform tasks that are best suited for deep learning. So I've walked you through the power of Cognex's Vidi deep learning tools. Those tools can all be integrated with the Insight D900. But let's review 3 Insight Vidi application tools designed for the D900 with ease of use in mind. VidiDetect for defect detection, VidiCheck for assembly verification, and VidiRead for optical character recognition. VidiDetect learns the normal appearance of an object, including its tolerable variations, and can then perform cosmetic surface inspection or functional defect detection. These 4 examples highlight the power of VidiDetect. With the approach I outlined, it can identify imperfections on a medical screw, defective soldering on circuit board assemblies, scratches on finished products or final assemblies, or even hard-to-find defects in textile applications. Let's look at that air filter example from earlier in a bit more detail. In the air filter inspection, the camera is mounted in a fixed location, and the air filters are rotated one at a time to complete a 360-degree inspection. As they're rotated, you can see how the mesh appearance changes drastically from image to image, including the metal joint passing through the region of interest. With or without that metal joint in the region of interest, VidiDetect can determine if each of these images fall within the category of acceptable variation, and so the tool passes both images as each one scores below the threshold set during the validation step. But when defects of different types are introduced, such as dents or tears or other deformations, VidiDetect can easily identify those defects just as a human would, whether those defects are large or small. This entire application was built in just a few hours, and the VidiDetect tool trained in just 10 minutes on a training set of 63 images. The next tool, VidiCheck, can be trained to find complex features and objects that are presented with too much variation for rule-based pattern matching tools. With VidiCheck, you can locate individual components of an assembly and perform quality checks on kits and packages. In these 3 examples, VidiCheck is being used to verify the proper assembly of an automotive fuse box, to validate the configuration of an interior car door, and confirming the presence and location of each item in a medical kit. Let me walk you through more detail on one of the applications solved with VidiCheck. This consumer electronics inspection is verifying that 2 contacts are assembled without being bent, and that an additional connector is properly seated. The Insight D900 is mounted overhead in a fixed location, and devices pass underneath the smart camera. If we magnify the various examples of the contacts and connectors used for training, you can see how variation in shape, contrast, and orientation and context around those components causes issues for rule-based vision systems. This application took a novel approach using the VidiCheck tool by only training the contacts and connectors in their good state, so that if a contact or connector was present but not assembled correctly and thus looks different from these appearances, the VidiCheck tool would not recognize the component. And let's look at how this plays out. In this upper image, the two contacts and connector are all assembled in a quality manner, and VidiCheck confirms that. The appearance of the contacts and connector, including the context around those features, matches what the VidiCheck tools were trained on, and hence it passes. However, in the lower image, the second contact is bent, and because of this different appearance, the VidiCheck tool fails the contact inspection. And yeah, there's a second contact in the field of view, but that isn't enough because of the way this user trained the tool to only find a properly assembled contact. In the same way, even though you can see the connector on the right, you can also see that it's not assembled properly based on the context around the end of that connector. So VidiCheck tool also realizes this subtlety and fails this second part of the inspection. The last application I will review is VidiRead, which deciphers badly deformed, skewed, and poorly etched codes using optical character recognition. The tool comes with a pre-trained font library that speeds up labeling characters, but the real power is unleashed when it's trained on the specifics of a given application. VidiRead has solved applications in nearly every industry from electronics, medical, automotive, consumer packaging, and many other industries where OCR is a quality, regulatory, or manufacturing process requirement. And it has done so where other rule-based vision systems have failed in the past. Have a look at the extensive amount of low contrast, distorted, and unevenly spaced characters Vidi is identifying. All of the Vidi tools are impressive, but because of the importance of OCR in today's manufacturing environment, VidiRead is one of the most important tools in our toolkit. For a deeper look into what's possible with the VidiRead tool, let's look at an OCR application on different plastic molded bottles. Each bottle is filled with a different color liquid, and inkjet printing of varying scale is placed on a different location with respect to the pattern on the bottle. The variation in background color and bottle texture alone would make it impossible to achieve a reasonable read rate with a single rule-based vision system. However, the Insight D900 achieved over a 99% read rate in this application. We've successfully identified and output the right character strings into the spreadsheet and onto the web HMI on a new lot of bottles that wasn't seen during development. In the first screenshot, look at how VidiRead identifies the 3 despite a line of contrast nearly splitting the character diagonally, and how it does the same with the 0 despite discoloration on the lower right of the character. And in the next image, you can see the VidiRead tool properly identifying a 9, where even you might be leaning in a little closer to the screen to ensure that this wasn't a 3. And finally, with a translucent liquid in the bottle, the characters do not have the same contrast, but as highlighted by the R and the 2, none of these challenges are insurmountable for VidiRead once it has been trained on the characters as they present in any particular application. We believe if you can train a human to read a given set of characters for an application, you can train VidiRead to complete it too. In summary, I introduced the Insight D900 series vision system, a breakthrough new product with the ability to apply both standard 2D rule-based vision tools and Vidi's deep learning tools. I recapped how Vidi tools work and how to use the new Insight Vidi software to train and validate the Vidi tools before deploying your Insight D900. And finally, I shared 3 top categories of applications that we see the D900 having the most success in automating: defect detection, assembly verification, and OCR. Contact your local sales representative today to see what the Insight D900 can do for you. Thank you, and now I'd be happy to take some questions.
Thanks, John, for your presentation. So with that, let's move on to a few questions. The first question is, what processing times can the D900 achieve in production? So
that's a great question, and the traditional answer is always, it depends. and that absolutely still applies. Every application is different. However, the D900 can achieve processing times as fast as 350 or 400 parts per minute, which allows us to enable a wide swath of applications, but certainly not every application just yet.
So we've got another question here. What industries have you made the most progress in with deep learning?
Yeah, this is another great question, and again, I'll give both a general and a specific answer. You know, I think there's no industry that cannot be served by these deep learning tools. So I will say all industries, whether it's automotive or consumer electronics, consumer products, and medical, packaging, et cetera. So really all applications, but traditionally Cognex has been the strongest, and other machine vision companies as well in automotive and electronic space, even in logistics areas. And so that's also certainly true here.
Great. And then another question that came in, do you offer customer training?
Yes, absolutely. And you know, the best way to get in touch with the training offerings we have, which include up to a 4-day in-person or now virtual training as well, with all the same content, is to reach out to your local sales representatives and to identify both your need as well as what type of training you want to get involved with.
Thanks again for your time, John. If we were unable to get to your question, we'll be sure to connect with you offline. Also, if you could take a moment to complete the brief survey by clicking the survey icon at the bottom of your screen, we'd really appreciate it. Let us know how we're doing and what else we can do to help you learn about and implement vision and ID solutions. We hope you found today's webinar to be helpful and informative, and we look forward to seeing you at the next Cognex online presentation. Thank you so much for attending, and have a great day.